before we start, a huge thank you to everyone in Argentina. You absolutely boosted the last home automation video, so this one is for you. This project was only possible thanks to my sponsor, with JLC PCB. So let's visit the JLC PCB page and get this board ready for production. Just drag and drop and boom! The boards are instantly analyzed and show exactly what you will receive. They offer us total control, quantity, thickness, color, everything you need to create the perfect board. Look, we can see the result of the board in 3D. What I love is the transparency. You adjust a setting and the price is updated in real time. They have industrial level features, but the interface seems to have been made for manufacturers like us. And if you're new, you can register right here. It takes a few seconds. Instead of jumping to a new automation idea, we're improving the light switch system. Today, we're building the three-way version. And this one makes way more sense for real homes. And yes, we're still using non-SMD components. SMD would make the board smaller, but it would also make it harder for people to build at home. Our goal is simple: give you the idea, the materials, and let everyone build, learn, and have fun. Just be safe. Seriously. A three-way switch lets you control one light from two locations, and this electronic version has to be the last switch in the circuit. Half of the board is already assembled, but let me show you the H11AA1. Home Assistant can toggle the relay and show the state, but if someone flips the physical switch, Home Assistant has no idea. The H11AA1 fixes that. It watches the actual AC output and tells us if the light is really on. We'll see this happen in the practical part, so let's finish the board. In the last video, our 3.3 volt regulator was having a moment. We received a lot of help from the community. Actually, nobody bothered to do this. And honestly, they did a great job. We're here to show you projects, not to ask you questions. So we upgraded to an AMS 1117. Good thing I said earlier that we weren't using SMD. This one is easy to solder, unlike the tiny PC817 we used before. The ESP01 support also got an upgrade. Easier to remove, cleaner design, and honestly, this might be the final version. Because we'll probably stop using the ESP01 soon. Too few pins and another issue we found. But that's for the next chapter. Time to test the circuit. This time, we're doing it on the bench. Much easier to understand. Quick connectors, a real three-way switch, our electronic three-way board, and a lamp to simulate the circuit. Focus on the circuit, not on my cable management skills. Let's upload the code, you know the drill. New device, give it a name, choose ESP8266, and hit edit. Here we insert a small piece of code. One part for the switch, and another part for monitoring the AC. I didn't explain it earlier, but the H11AA1 is an optocoupler, which means it's safe to use because there's no direct electrical connection between the input and the output. Inside, it has two LEDs and a phototransistor. The LEDs connect to the AC circuit, and when they light up, the phototransistor creates tiny electrical pulses that the microcontroller can read. This is a very simplified explanation, but honestly, it is that simple. We've already sent the code to the ESP, and sometimes you'll see this integration issue where it asks for a key. That key is already in the code. Just copy and paste it. And we're online. Now let's quickly add it to the Home Assistant overview so we have a clickable switch and can see how everything behaves. Let's see it in action. First, install the ESP. The new support looks much better and way more practical. Next, a quick voltage test. And here you really need to be careful. We're dealing with 240 volts. This can destroy the device, and it can seriously hurt you if you're not paying attention. With the lamp on, we get the high voltage we expect. And on pins 4 and 5 of the optocoupler, with the light off, we should see around 3.3 volts, and with the light on, it should drop to 0 volts. That gives us the high and low signals the ESP needs. Everything seems to be working perfectly. I tap the button in Home Assistant, the light turns on. That deserves a like, right? Yeah, probably not. Now I turn it off using the physical switch, and Home Assistant updates instantly. Exactly the result we wanted. And yes, I wouldn't show you this if it didn't work. Time to write more documentation. Don't worry, I'll handle that. Another project, another update. And more are coming. We're already planning to integrate an RF transmitter into this board, opening gates, triggering devices, lots of new ideas. But that's for the next video. This video is short, so don't even waste time subscribing. See you in the next one, and thanks for watching.